Hello everyone, good day. This is grade 5, the activity number 4. So we have the title of problem solving and reasoning, and also we have the theme understanding the importance of reasoning and if-then statement and converses. So today we are going to tackle about and give some examples about reasoning and if-then statement and converses. So what is problem solving? It's a mathematical process which is found in the strand of mathematical process along with logic, reasoning, and communication. This is the side of mathematics that enable us to use the skills in wide variety of situations. So what is reasoning? Reasoning is a process of applying logical and critical thinking to a mathematical problem in order to work out the correct strategy to use in reaching a solution. So there are types of reasoning which are inductive reasoning, deductive reasoning, institution reasoning, and analogy reasoning. So now let's proceed to the types of reasoning.
Inductive reasoning is the process of gathering specific information, usually through observation and measurement, and then making a conjecture based on the gathered information. For example, so take note that the sum of the square of the number of odd number is being added. So this is the solution. 1 plus 3 plus 5 plus 7 equal 4 to the second power equal 16. So the odd is number 4. And the second one is 1 plus 3 plus 5 plus 7 plus 9 equal 5 to the second power equal 25. So the odd number is number 5. From this note, we can make this conjecture. The sum of the first n odd numbers is n to the second power, or 1 plus 3 plus 5 plus 7 plus 9 plus cos parenthesis 2n minus 1 equal 2 to the second power.
Deductive reasoning is a logic approach where you progress from general ideas to specific conclusions. It's often contrasted with inductive reasoning, where you start with specific observations and form general conclusions. Deductive reasoning is also called deductive logic or top-down reasoning. For example, A is equal to B. B is also equal to C. Given those two statements, you can conclude A is equal to C using deductive reasoning. Another example, all spiders have 8 legs. A tarantula is a spider. Conclusion: therefore, tarantulas have 8 legs. For deductive reasoning to be sound, the hypothesis must be correct. It is assumed that the statements, all spiders have 8 legs, and a tarantula is a spider are true.
Intuition. Intuition is the ability to acquire knowledge without recourse to conscious reasoning. Different fields use the word intuition in very different ways, including but not limited to direct access to unconscious knowledge, unconscious cognition, inner sensing, inner insight, unconscious pattern recognition, and the ability to understand something instinctively without any need for conscious reasoning. Intuitive knowledge tends to be approximate. One such example addressed the issue of comparing the number of elements into two infinite sets. A common intuitive response is the number of elements in an infinite set is greater than the number of elements each of its infinite proper subsets. A response based on our experience with finite set.
What is an analogy? An analogy is a comparison of two things in which one idea or concept is compared to something entirely different. While the two things might be totally different, the analogy compels the reader to realize their association. Sometimes the analogy provides a comparison between two similar things, one of which might be hidden. The analogy gives a reader a way to understand the hidden thing by picturing the more common thing. Example: time is money, so spend it wisely. She is as busy as bee nowadays. She is as light as a feather. Socks are just the gloves of the feet. There is a garden on his face. Another example. Find the odd one out. A2, B4, C6, D7. So the answer is 7. Like all other numbers, 2, 4, 6 are even numbers and divisible by 2, whereas 7 is an odd number.
If, then statement and converses. So there are the following if, then statement and converses, which are conditional, hypothesis, conclusion, converse, and biconditional. Conditional is a statement that consists of hypothesis and conclusion. Hypothesis: the hypothesis of a conditional state that the given facts are assumed as true. Also, this is found in the if part of conditional. Conclusion: the conclusion of a conditional state that needs to be proven or established or true. This is found in the then part of conditional. Converse: a given conditional is formed when the if and then parts are reversed. Last, biconditional is a statement that combines a conditional and its converse with a phrase if and only if, which means as if.
Conditional statement. If today is Wednesday, then yesterday was Tuesday. Hypothesis. If today is Wednesday, so our conclusion must follow. Then yesterday was Tuesday. So the converse is found by arranging the hypothesis and conclusion as math planet accurately states. Hypothesis followed by a conclusion is called an if-then statement or a conditional statement. This is noted as FP then Q. A conditional statement is false if hypothesis is true and the conclusion is false. Examples of hypothesis statement. If garlic repels fleas, then a dog that is given garlic every day will not get fleas. If I add fertilizer to my garden, then my plants will grow faster. If ultraviolet light can damage the eyes, then maybe this light can cause blindness. The conclusion summarizes your report, giving information about the problem that you had to solve, the mathematical processes you used to solve the problem, and discussion on how you solve the problem. For example, the conclusion of if a line is horizontal then the line has slope 0. Is the line has slope 0? In mathematics, you will come into many if-then statements. For example, if a number is even, then it is divisible by 2. To form the converse of the conditional statement, interchange the hypothesis and the conclusion. The converse of if it rains, then they cancel the school is if they cancel the school, then it rains. To form the inverse of the conditional statement, take the negation of both the hypothesis and the conclusion. By conditional statement examples, the polygon has only 4 sides if and only if the polygon is a quadrilateral. The polygon is a quadrilateral if and only if the polygon has only 4 sides. The quadrilateral has 4 congruent sides and angles if and only if the quadrilateral is a square.